Inductors in parallel. Consider two inductors L1, L2 are connected in parallel. This is inductor L1, this is inductor L2. The current, let current passing through the inductor L1 be I1 and the current passing through the inductor L2 be I2. Next, voltage across inductor L1 be VL1 and voltage across inductor L2 will be VL2. Next, the equivalent of this circuit, that is two inductors connected in parallel, is replaced with a single equivalent, that is L equivalent. Current passing through this is I and voltage across this equivalent inductance is VL. We know that the current passing through the inductor, that is the expression for current passing through the inductor IL is equal to 1 by L1 integral VL dt. This is the expression of current passing through the inductor. IL is equal to 1 by L integral VL dt. See here, next current passing through this equivalent value of inductance, that is I is equal to 1 by L equivalent integral voltage across this, that is VL dt. Let it be, this is the expression 1. Similarly, the current passing through the inductor L1, that is I1, is equal to 1 by L1 integral voltage across this inductor L1 is VL1 dt. Next, similarly, I2, that is current passing through the inductor L2, is 1 by L2 integral voltage across inductor L2 is VL2 dt. In parallel circuit, this is expression 2. In parallel circuit, we know that current, that is total current in the circuit, is equal to the sum of the individual currents passing through the elements. That means, for suppose this current I is considered as total current in the circuit. Okay, here this is total current in the circuit, and it divides it into two currents, that is I1 and I2. Then this total current I is equal to sum of the individual currents passing through the elements, that is I1 plus I2. Next, we know that voltage across all the elements is the same, that of the supply voltage, that is let VL, that is the applied voltage or total voltage which is across the combination of two inductors connected in parallel is VL, that is same as that of the voltage across inductor L1, that is VL1, and same as that of the inductor voltage across inductor L2, that is VL2. In parallel circuit, voltage same and current divides. Now substitute these two expressions in this expression, we may get, in place of I, we may write 1 by L equivalent integral VL dt, that is equal to, next what is I1? In place of I1, we may write 1 by L1 integral VL1 dt. 1 by L1 integral VL. Okay, in place of VL1, you may write VL because in parallel circuit voltage is same. Okay, VL plus I2. I2 it is 1 by L2 integral VL2. VL2 is VL. Again we write VL dt. Next 1 by L equivalent integral VL dt is equal to 1 by L1 plus 1 by L2 integral VL dt, take it as copy. Okay, these two get cancelled. Then 1 by L equivalent is equal to 1 by L1 plus 1 by L2. That means reciprocal of equivalent inductance of the parallel combination is the sum of reciprocals of the inductances. That is 1 by L equivalent is equal to 1 by L1 plus 1 by L2. Similarly, for n number of inductances in parallel, 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus and so on plus 1 by Ln.